Chris Doherty here, technical editor for Motorhome and Trailer Life, and we're here at Tim's RV in Irving, Massachusetts to do an install of a new Xantrex power system in this Newmar Kountry Star motorhome that we have behind us. And the owner of the coach is Bob Miller, who's right here with us. Hello. And then we have Brandon Turner, thank you, who is the chief technician here at Tim's. So we're going to be putting this in. We're also going to do some solar, which we'll show here in a minute. But so what do we got to do to get this stuff in? First of all, this Xantrex, this is a 2,000 watt inverter, and we already have a 2,000 watt in here, right?
That is correct. Okay,
so the big difference is this is pure sine wave. Mm-hmm. That one is not. It's an older style. This is a 2005, right?
Correct.
Correct? Okay. So we have a 2005 motorhome. It has a modified sine wave inverter in it, which is not net workable. So we're going to actually upgrade this coach to the newest technology that's available. And so this is a 2,000 watt pure sine wave inverter charger. So it's a 100 amp charger, as well as being a 2,000 watt inverter. And it's net workable, which means that these other components all tie together in a network that allows all the pieces to communicate, and then you can also access them via a smart app. So we're going to be doing all this install here, but it's actually going to be pretty simple, because this one we don't have to change fuses or battery cables or anything on this, right?
Correct.
So we're going to put that right in there. And how about the data cable going forward?
We're able to use the existing data cable that goes up to the front, and using these adapters, because the old 2005 they were using more of a phone style cable, or an RJ15 I think it's called.
RJ15, okay.
15, and this is the new components use a RJ45 or a Cat5 cable connector. So we're going to use these adapters and be able to use the existing wire that is already run front to back, which simplifies the job immensely.
Real easy. So, and then we'll take the existing display out, and we're going to put this new programmable one in. And so you'll be able to control everything that the inverter can do via this control panel, which is pretty cool. And we're also going to add another feature. We're going to add automatic generator start to the system. So when you're dry camping, if you are running loads in the RV and it decides that the batteries are too low, this will automatically start the generator and charge it. You can also program quiet hours and different things into it. Also, as an option, you can also wire this to a temperature sensor that will automatically turn on the air conditioning, the generator, and then the air conditioning in the coach. So that's a nice feature. It's a little more involved, but it is certainly doable. And then we have what's called the Conext Combox, and this is kind of the brains of the operation. So this connects all the different components together. It hooks up with the networking cable, which they call a XAN bus. And then we're also going to connect that to this router, which is going to allow people with a computer or a smart device to get in and program the system. New from Xantrex, our Test Solar Max panels are premium, lightweight, and flexible peel and stick solar panels, available in kits and expansion kits in 80, 165, and 220 watt sizes. They're tear and corrosion resistant, and according to Xantrex, the patented mesh wire technology offers up to 20% more energy harvesting in real-world conditions. So we don't have a lot of wiring to do in this because there is an existing system here already, but we've got a few things to look at, so we'll take a look. You guys ready to get started?
I'm ready.
All right, let's do it. So to start off with here, we have removed the original inverter equipment. We isolated the batteries from the system, and we are not going to trust the cables, the wiring that went into the inverter. Instead, we're going to test each cable independently so that we know where each one goes and comes from. We check and double check these wires so as not to do any damage to the inverter. Next, we're going to install the replacement inverter, and this may require a little bit of carpentry or steel work depending on the design of the replacement inverter. So older models are set up a little differently. Their battery cables are in different spots, and so we needed to spend some time with this, just making sure that we had things where we wanted them. We run the battery cables to the appropriate terminals and secure them. And then we're also putting in some strain reliefs to run the Romex cable in. So we put in a separate box and we're making extensions for those. At the same time, we're going to run cable for our new solar system using the Solar Max panels. And the kit comes pretty much complete. So it has a charger unit already included, but we did add a solar fuse setup, as you see here, from Little Fuse, which allows us to fuse both sides of the solar wiring system. While we're checking wiring, we also hooked up the adapters to the RJ11 wiring that was existing in the coach so that we could put the control panels in. And we opened up the dashboard and the overhead compartments so that we could run additional wiring and also install the Xantrex Auto Gen Start. This is a 2005 Newmar. It did not have Auto Gen Start already. So we found a way of putting it in here, and to be perfectly honest, it took quite some time to get the wiring just right for that. Once we got that all set, we turned our attention to the roof, and the roof had been replaced on this coach, and they had taken the original solar wire, there was 10 gauge solar wire already up here, and wrapped it around this vent so it would be accessible in the future. And so we found that cable and ran it up so that we'd be able to access it on the roof. Then we were able to use the Xantrex cable to make wires for our new solar installation.
So we were just looking at these MC4 connectors before we attach our solar wire that Xantrex supplies, attaching to the wires, 10 gauge wires that are already run up from the compartment where the charge controller is. And I was taking a look at these connectors because these are positive negative connectors. So this is what a positive connector looks like, this is what a negative connector looks like. And with solar applications, you have to make sure that you put the right end on, because positive doesn't always mean positive when you get into running strings and things like that. So if we take our positive coming off of the panel, this is our positive coming off of the panel, and we use our branch connector, what it needs to plug into is actually a negative connector, but Xantrex has already taken care of that for you and gone ahead and put that on the red wire, so they knew that you were going to be doing this. So it was a nice feature that they put together so that someone wouldn't put the wrong connector on and then realize later that they had done the wrong wire. So yeah, just a nice feature.
So the next thing that we're going to do is attach the solar panel cables on the roof to the existing 10 gauge cable that is coming up from the utility compartment. And then we'll secure these inside the roof. Now we've drilled a separate 2-inch hole through the roof, and we have a clamshell that we're going to use to seal that up when we're all done, and the cable will just come out of the clamshell and go directly over to the solar panels. So you can see here we've made our connections and we put on the appropriate ends as Brandon had demonstrated earlier. This is an important part of the process, and while the Xantrex equipment does come with all the cables and things that you need, there may be times where you're going to have to make some of your own connections, and it's pretty straightforward. And as far as crimping on the solar connections are concerned, they do make tools and so forth that you can buy on Amazon or other electrical supply places, solar supply places, to make these connections. But again, it's very important to make sure you have positive and negative correct on all of these. Now, in addition to using a crimp tool on these, we're also using heat shrink connectors. So we want to make sure these are sealed up real well, because we're going to be hiding them inside the roof, and there shouldn't be any moisture on the inside of a roof, but especially with this coach, has a brand new one, but we want to make sure everything's right. whenever you're installing something on an RV roof, make sure you reseal everything very well to prevent leaks. So we've removed a vent cover here. We made a new hole that we're going to use clamshell to connect. So we're going to make sure when we put those back down that they are, of course, properly sealed. Now it's okay to use a little lighter stick like this to melt the self-sealing crimp connectors, however, solderless connectors. However, a small torch also works very well for this. It can be a small utility torch. Same kind of thing you use for heat shrink when you make custom cables like battery cables, that type of thing. So we used the heat shrink solderless connectors, and then also used a heat shrink sleeve over the top of that. So it's really a super well sealed connection. Now these are the Solar Max panels that we're going to install, and there's a couple of different sizes which you match up to the coach that you're going to install them on and the customer's preferences for how much power they're going to need. These are self-stick panels. However, once you prep the roof, which you need to do with some isopropyl alcohol, make sure it's very clean. You're going to put these panels down, and then you need to use another product to help hold them down. Xantrex recommends that you use 3M VHB tape around the outside of the panel. VHB stands for very high bond. As an alternative, we decided to use a Turnabond tape around the panels, which helps to seal them in a little bit better. Either way, it works well to help hold the panels down, but the adhesive that comes on the panels is not designed to be the only thing to hold them down, so that's very important. Of course, if you have any problems with your roof or roof membrane, you want to make sure that those are corrected before you put your panels down. Now, before this, we had measured out exactly where we wanted the panels, and we marked them with a Sharpie on the roof so we knew exactly where we were going to put them down to make them look nice. And you know, even though no one's necessarily going to go up there and see them, you still want to do it as nicely as possible. In this particular case, we did it so that the cables face the center, and then we're going to screw them down and run them back to connect with the wiring coming out of the roof. You can take a roller like this is an Turnabond roller, and roll around the edges to make sure that they're secured, but don't roll on the solar array itself. So the actual cells are a little bit fragile, so you don't want to be rolling on them. They'll put up with quite a bit. You can actually roll these panels right up if you need to, and they'll still produce power also if they're broken, but you want to try to be somewhat careful with it. So here Brandon is putting down a Turnabond tape, and this is going to help seal around the whole outside of the panel, so it'll keep everything out from underneath it. Depending on the style of the panel, some of them have less room around the cable inlet than others, so you'll want to take a look at that before you put the tape down. So if you don't have enough room to seal underneath the cable, you may want to use the 3M VHB double-sided tape underneath instead of the Turnabond. But as you can see here, the Turnabond tape makes a nice, clean, seamless installation. It seals the panels down very, very well. So once the panels are fully installed, then we're going to work on getting everything else connected and resealed. So here we put the sewer vent back in place, the base of it. It has butyl tape underneath to help seal it down, and then you use the same screws you took it out with to screw back down into the deck. So again, here Brandon is being very careful to connect the solar panels correctly with the proper polarity. And the cables from the solar panels themselves come with the proper connectors on them already. So then you're just going to use the junction blocks to put everything together. So here we're measuring out where the cables are going to go, and we want the installation to look nice. We're going to need access to these junction blocks later on if we want to add panels to the installation. So before we put the clamshell down, we're going to run all the cable, and we're going to use these cable clamps to screw them down to the roof deck. Again, you'll want to take your time doing this and make sure you have things nice and tidy and well secured. As far as cable clamps are concerned, you should use metal ones that are wrapped in plastic or rubber. Do not use the straight plastic ones. They're not UV stabilized, and they'll fail pretty quickly on the roof environment. Now, speaking of which, the rest of this cable and those cable connectors are designed for outside use, so they'll actually hold up very, very well. When you're putting the panels down, you want to make sure that you're going to have room to walk in and around the panels. And so you make a kind of a decision as to where you're going to put them. You can have them in line on one side of the unit. You can put them side by side like this. You have some different options, but you want to be able to walk around them. You do not want to walk on these panels. Once these panels are installed, other than checking sealants around the hardware and so forth, as you would normally do with a roof inspection, there's no other maintenance to do up here. So as you can see here, we're just figuring out what the best layout for this is going to be. He's secured down the cable coming from the solar panels themselves. And so we have the clamshell, which we've applied butyl tape to the bottom of. And this clamshell is made by Winegard. There's a couple of other ones out there, but these are available online for sure, or from your RV supplier. And you'll see this is a dual cable model, so it will accept 2 wires in the spacing. And do make sure you use all the screw holes, and you want to screw them down well all the way around so that you're squeezing the butyl out a little bit. And you need to make sure this is facing the rear of the coach, as you can see here. So that's when you're driving down the road and you have a driving rain coming into it, you don't want to be forcing the water in and around where the cables come in. And you just want to try to eliminate openings as much as you can. Butyl tape's good in that you can form it and you can kind of press it around and seal it down real well. So this is one of the things you want to do just to make sure you don't have leaks. So these self-adhesive panels are really great in that there's no big hardware. The panels themselves have no screws that go in the roof, so it's eliminating or reducing the number of screws that you're going to use. Nothing should get underneath them, so when you have aluminum frame panels up on brackets, a lot of times you'll get detritus underneath the panels and it's just difficult to keep clean. While you can't certainly aim panels like this, some people do like to be able to aim panels to maximize the solar energy collecting abilities of the array. They're going to do pretty well, and they're designed to be in that flat position. Whenever you're sealing something on an RV roof, you want to get around the outside of it very well. Any place where cables are entering, you want to make sure those are sealed up well. So here they're injecting a little bit of sealant around the cables. Make sure every little bit's covered. And then they'll go back and touch up where all the screws are. And once we're done sealing this up, our job on the roof is done. Okay, so Brandon, this is where we put the solar equipment, the charger and your wiring, fusing. So let's go through that here. Where did you install and where did you install it?
Charge controller we mounted up here in the corner out of the way so that the bay could still be used. We ran our solar wiring from the rooftop down into this DIN rail mounted fuse holder. There's no fuse in it right now. That's the PV fuse. So the power comes in here, it's fused, and then feeds into the charge controller. After it goes through the charge controller, it comes back and it's fused at the battery fuse on the same DIN rail before it goes to the battery.
Okay. And what's the solar controller going to do for us?
The solar controller monitors the charge of the battery, so it will not allow the batteries to overcharge. So it will keep track of the charge on the batteries and use the solar appropriately as it's coming off the rooftop.
Now, this solar kit from Xantrex comes with an ATC inline fuse. You used a little bit something different here. Can you tell us about that?
Yeah, this is something that we had here from some other solar projects. This is a DIN rail, which is a small rail that you can mount any type of terminal blocks or fuse mounts. Just makes it a real versatile way to do this type of mounting on a wall here. We could have used the inline, but I think this is a little cleaner look, and I just like the install better. And
this also allows you to disconnect the solar.
It does, yeah. These fuse holders you can open up and use as a disconnect. So that's another reason I do like them.
Okay. And then when you were doing the install, you could also test for voltage. So you were testing to make sure that you were good from the panels coming down off the roof.
Make sure we had our voltage coming down.
And then also that we were connected properly to the battery. So we were making sure that polarity was correct.
Yeah, before we put any fuses in, we checked the polarity and we made sure that we had battery voltage here at the fuse holder.
Okay, fantastic. So as you can see here, we have a nice, neat installation. We have our little fuse power safe fuse blocks here. So we can open these up and insert our fuses. And this is, once we close these, then the system's going to be active. And it's all connected to our batteries, and we have everything tied together very nicely here. We move back over to the other side of the coach and we have our Freedom SW 2000 watt inverter. Everything's nicely installed. Here we have the Xantrex Conext Combox, which is tied into all the components, and the router with a special power supply that we put in place to operate it off the 12-volt system in the coach. That way you can access the how the system is operating at all times, and that seems to work pretty well. Then we go back up inside the coach to the front panel, and this is the SCP, or System Control Panel. And this is going to allow us to have full control of the system, which is really very useful. So we can turn our charging on and off, we can turn the inverter on and off, we can change the type of charging that we're doing, because again, if you have different types of batteries, AGM, or flooded lead acid, or gel cell, or lithium iron phosphate, you'll be able to change the charge settings in here that are appropriate for whatever type of batteries you actually have. You'll also be able to access all this information on a smart device, either Android or iOS. Xantrex has apps for both, so that you can see what's going on and control the system from your smart devices. And last but certainly not least, you have full control of your automatic gen start here, as well as your quiet hours and temperature settings if you have it hooked to your air conditioning and so on.